So yeah, today's session is about CodeVita Round 2, and that's what we're going to cover. This is what we have in plan, and what I'm going to do is cover one CodeVita Round 2 question, and we're going to then look at some more Round 2 questions in future sessions as well. But today we look at one Round 2 question so that you will get to know how to prepare for Round 2 at the very least. I can confirm that Round 2 is not tomorrow, that is today 6th November. Round 2 is not on 6th November and it is not on 7th November. And the best place to confirm this is on the campus commune page. You should always open up the campus commune page, and that will tell you exactly what is the kind of dates, etc. you should have. And the thing is, it's very weird that they waited so long to actually declare that it's been postponed. So that's what I am just going to show you over here as well. That if I just go here, yeah, if I go here, this is the campus commune page. On the campus commune page, you have the pre-qualifier, the zonal round, which all of you have given. If you're part of this, oh, sorry for that, 1 second. But yeah, if you've been part of this particular CodeVita Round 1, so if you've been part of CodeVita Round 1, then obviously you know about the campus commune page, and you also know that there's a pre-qualifier round which you all have given, and hence you could be a part of the qualifier round. As you can see, it's moved to 2021. It's moved to,
yeah, sorry everybody.
sorry.
Yeah, no, I know that.
Yeah, so now I got the sound check also, everyone. But yeah, so Feb 2021 is the round 2 as well, and the grand finale being in May. So really almost a year after the CodeVita season 9 started is when they will actually conclude it, which is very strange. Usually they don't wait so long, but we can all understand that whatever you call it, like the pandemic, the situation has been so difficult. So it's been so difficult for them as well. So they are not being able to manage it as well. So even then, you are here, you are all, we have like lots of people watching right now. Do like the stream so that we know that you like this kind of content, and subscribe to this channel so that more people come to know about this as well. But so you're here, I would like to share with you some tips and tricks for solving one question, solving questions. What are the topics you should solve it on? And I'll be solving one question today for all of you. So there'll be one question that we will all solve today itself. And this question is also available on the Edyst platform, and for the remaining sessions we can also for the remaining questions we can do it on a later date closer to CodeVita Round 2 to prepare there. Okay, so some of the major topics that you should prepare for CodeVita Round 2 is advanced maths and advanced arrays. I can't stress this enough. Advanced maths and arrays means that questions like, you should really have a good knowledge of permutations, combinations. You should have a good knowledge of modular arithmetic and all of that. That's really important. You should have a good idea of that, right? So that's really important for you to know advanced maths, advanced arrays, and so on. We will cover an advanced arrays plus advanced maths combination question today. We'll have a look into that right now. Plus backtracking DP. So generally I think probably the 5th, 6th question will again be from backtracking DP. In fact, I was looking up last year's round 2 questions, and I could see that even the starting 1 or 2 questions could be from DP as well. Graphs questions are also very important, especially like in graphs, all of the important algorithms you have like Dijkstra, Kruskal, Prims, everything that you require, like this and more. The thing is, they will ask you not this but a combination of these things. So last year I had students who had completed the graphs question, but they had almost derived Dijkstra by themselves again, which is not what you're supposed to do. These are already established algorithms. Don't try to derive a new algorithm again. Keep the previous algorithm, and you should be aware of these algorithms. So we'll be covering some of these in future sessions of ours on CodeVita Round 2 part, but this is some of the major topics that they ask. And so what I'll be doing is doing one question today, which is called a prime counter, and we're going to look at 2 concepts of advanced arrays and maths in that. One is the sieve of Eratosthenes, which I think most of you will be familiar with on prime numbers and how it's so important to calculate prime numbers using sieve. And we'll be looking at something called prefix sums. So these are the 2 concepts that we'll be looking at together: prefix sums plus sieve of Eratosthenes. These are the 2 concepts we're going to be looking at together from advanced maths plus advanced arrays. All right. However, before I go ahead, one thing that I wanted you guys all to know just a small announcement from our side as well. If you are a student who wants to know advanced topics like all of the topics that I mentioned above, if you want to prepare for maths, arrays, if you've cleared CodeVita round 1, there's a good chance that you can prepare enough and also crack product companies. So if you want to do that, we have a new bootcamp that we have launched called the Advanced Data Structures Bootcamp. You can check up the link over here, and you can also go through the entire video that we did this on how to crack high packages at product companies. So we'll be you can go ahead and check that video. And we have this new boot camp coming up. It's very a lot of students already started giving us really good reviews, saying that being from a tier 2 college, tier 3 college, they've never knew how to crack a product company. This boot camp is already helping them do that. Students have got packages up to 24 lakhs per annum just by going through this boot camp. So if you really want to up your game and know all of those topics, don't just stick to the free webinars that I am doing right now. That those are important, and I'll introduce certain concepts to you. But if you really want to get into the product companies bit, this is the bootcamp that you should join. So click on this link. It's also mentioned in the description below, and you can pick up this question as well. So that was the small thing about the advanced algorithms and data structures bootcamp. Now let's open up the question called the prime counters question, and I'll open that up on the Edyst platform by going to the Edyst CodeVita course. And if you don't know where the Edyst CodeVita course is, simply it's in the link in the description below. You can get that. It's in the course below as well. For those of you who've joined us late, CodeVita round 2 is on 6th February 2021. It is not tomorrow. It is not on 7th November 2020. So just to let you know about that. Anyways, I will be opening the CodeVita 2020 course right now. I'm opening the CodeVita 2020 course. Here we go. And in that CodeVita 2020 course, I am opening up basics of CodeVita, and there is this question over here in called bonus season 8, and it's called prime counters. Okay, so in bonus season 8 prime counters, this is a round 2 question. Okay, so although it is from season 8, it's a round 2 question. All right. Okay, so before I read the question, I just would remind all of you how this works. If you have any doubts or questions, please post them in the chat, and we'll be more than happy to help you help you with those questions and doubts as well. And if my team is online, they'll answer your questions. If they don't answer your questions, I'll answer them after the session is over with whatever the chat questions you have. That's number 1. Number 2 is I will be sharing, I'll be now covering this question with the approach right now as it is over here, right? So let's get started on this question here. Okay, so this is a question from previously a CodeVita round 2, and what the question says is, given a number n, let Cp of n denote the number of primes between 1 and n inclusive of n. Okay, let's first understand this itself. Okay, the number of primes between 1 and n inclusive of n. Let's first try to understand this itself, what this particularly means, right? So if I look at Cp of n, I want to know how many prime numbers are there between 1 and n inclusive of n, right? So I'm just going to pick up my slides. Okay. So here we go. So if I look at like something like Cp of 1, I'm going to get 0, which is nothing but the number of primes that I have between 1 and 1 included. I have 0 primes. If I look at Cp of 2, I have 1 because there is 1 prime, right? Cp of 2, there is 1 prime. So again, just to let you know what are the prime numbers, you guys will all know. Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on, right? We keep going with them. So your Cp of 2 is 1 because there's only 1 prime number between 1 and 2, both inclusive. There's another Cp of 3, it will be equal to 2, right? Then you have Cp of 5 is equal to 3, okay? Because including 5, there are 3 prime numbers. And then Cp of 4 is still equal to 2 because between 1 and 4, you have 2 prime numbers, right? So between 1 and 4, you have 2 such prime numbers. So that's what the Cp means, that between any 2 numbers inclusive of itself, how many prime numbers do you have? So I hope you got this, what Cp is. Cp is nothing but between 1 and that number, how many prime numbers are there. So between, let's say if I do Cp of 20, how many prime numbers do I have below 20? You have these prime numbers, right? Which is 8 prime numbers below 20 is what you have, right? Okay, all right, great. A lot of people watching the stream right now. Do hit the like button and subscribe so that more people can come to know about it. Anyways, let's go back to the question. So what we have in the question is, given a number n, let CP denote the number of primes between 1 and n. If it was that simple, then this wouldn't be a round 2 question. We have to go a little bit one step further. We call n a prime counter if CP of n is a prime. Okay, so n need not be a prime. Okay, so for example, if I go back to all of my CP, right? If I go back to all my CPs over here, right? So these are all my CPs, right? And I say that so CP, right? So I of these up until 5 at the very least, okay? So up until 5, which are all of those prime counters? So we call something as a prime counter if, so n is a prime counter, n is a prime counter if CP of n is prime. Okay, so we are checking the primeness of CP of n. For example, CP of 1 CP of 1 is equal to 0, right? So if CP of 1 is equal to 0, is 1 a prime counter or not? No, 1 is not, let's say, prime counter, right? Because to be a prime counter, the CP of that number has to be prime. So CP of 1 is 0, so it's not. Which are the prime numbers, which are the prime counters we have? Well, we have 3, 4, 5 in this list at least, right? So if you check 3, 4 and 5, their CPs are prime themselves, right? Their CPs are prime, correct? You have CP3 is prime, CP4 is prime, CP5 is prime. So CP3 is 2, excuse me. CP3 is 2, CP4 is 2, CP5 is 3, CP6 will continue to be 3, CP6 will also be 3, because less than 6, how many primes are there? There are 3 primes. CP7 will be 4, right? And so if CP7 is 4, you know that 6 is a prime, but 7 is not a prime, right? So in the sense that 7 is not a prime counter in itself, right? So 3, 4, 5 are prime counters, even 6 is a prime counter, but 7 is not a prime counter over here, right? You can clearly see that because 7 has 4 CP. The value of CP is 4. Okay, so anyways, let's go back to the question. Let's finish reading the question now. So in the question we have CP7 is equal to 4 is given to us, right? Excuse me. Yeah. So in input, we'll have an integer t, number of test cases t, lines each containing 2 positive integers L and R. We have to output those t lines, right? We have to output those t lines containing the number of prime counters between L and R. So we don't only need the prime counters. We don't even need to find out like how many prime counters are there. We need to find out between L and R how many prime counters are there. So for example, one of the inputs that could be given to us. So for example, here we know that 3 is a prime counter, right? So how many prime counters do we have? Prime counters themselves, right? So if I wanted to figure out how many prime counters we have up until, so if I look at it like this, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up until 1, we have 0 prime counters. At 2, we still have 0 prime counters because 2 itself is not a prime counter because CP of 2 is 1. Okay. So how do you count if it's a prime counter? How do you know if it's a prime counter? You know if it's a prime counter if CP of that number is prime. Okay. Remember that. What is CP? Just rewind a little bit. You will find out what CP is. Okay. But CP of that number has to be prime. CP of 3 is prime, so this is a prime counter. CP of 4 is a prime, so this is a prime counter in itself, right? CP of 5 is a prime counter. CP of 6 prime counter. CP of 7 is not a prime, it's not a prime counter, so let me call it as n over here, and I'll put this as yes. Okay, I'll put it as y instead of y. N. This is not a prime counter. 9 is not a prime counter. 10 is not a prime counter, right? So if I had given you between 1 and 10, can you tell me how many prime counters? If I asked you, okay, between 1 and 10, can you tell me what are the number of prime counters that are there? You have to count the number of yeses. The number of yeses that are there are 4. So therefore the answer for that is going to be 4. That means there are 4 prime counters over here. Okay. Yeah. So if I just go back to the question and check it out, I'll see the same thing, right? So between 1, this is the inputs basically. Between 1, 1, 0 is basically 1 test case, and 1 and 10, right? That's what we're given here. So 1 second, I think the format of the input is a little bit wrong. It's not supposed to be in one line, it's supposed to be in multiple lines. We'll get that fixed right away. In fact, as we speak, let me just fix that up for all of you so that we can look at the question in the correct way. Meanwhile, please tell me, what would CP of 20 be? So what would CP of 20 be, and what's the prime counter between 1 and 20? How many prime counters are there between 1 and 20? Just tell me that while I just get this thing fixed, this formatting fixed. Just give me 1 second. Yeah, just getting the thing. Come on, let me know in the chat, everybody. For 20, what would the result be for 20 as well? Do let me know in the chat. 1 second. Here we go. Yeah. Okay, so we have updated it, I guess. 1 second. Yeah, let me just refresh. It should be updated now. Okay, just refreshing, guys. Just changing the format so that we all have the correct format over here when we look at it. Okay, so let's go. Come on. Okay, so as you can see, yeah, so we have 1 is the number of test cases, and it's asking between 1 and 10 how many prime counters are there. So as we saw in our question, right? So as we saw in our question, that there are 4 y's, that is, there are 4 numbers that themselves are prime counters. Therefore, between 1 and 10, both 1 and 10 being inclusive, you have 4 such prime counters, right? So the answer would be 4. Let's look at another one. Let's say if 11 was here. If 11 is here, CP of 11 is 5. If CP of 11 is 5, then it is a prime counter, so it becomes Y, right? And if I ask you between 1 and 11, not just 1 and 10, but let's say if I make it 1 and 11, so the number of prime counters I have is 5. Okay, all right. But if I ask you not between 1 and 11, if I ask you between 6 and 11, you will say 2, because 6 is a prime counter, then 7, 8, 9, 10 are not, and then 11 is a prime counter. So 6 and 11, I have 2 such prime counters, right? Okay, great. All right, so let's see how we'll go ahead and solve this question. Yeah, so this question actually involves 2 concepts. So this question involves 2 concepts, and I'll tell you what both those concepts are. Okay, let's look at our prime numbers, right? So let's look at all our prime numbers, and I'm just going to remove the indexes because we don't really need the indexes. Okay, sorry. Yeah, let me just remove this. So let's look at all our prime numbers that we have so far, right? So we have the prime numbers over here called, let's start from 1. 1 second. What's the best way? Okay, we'll do it in another way. Let's keep them. Okay, so we'll 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, right? So we'll keep this here. Let's keep this as the prime numbers, right? And we'll put a true if it's a prime number. So this is false, not a prime number. 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, 6 is not a prime number, 7 is a prime number, 8 is not a prime number, 9 is not a prime number, 10 is not a prime number, 11 is a prime number, 12 is not a prime number. Okay, so this is what you have. Now the question becomes, how do we get the CP, right? So we need the CP, right? So if you take the CP over here, CP is nothing but the number of prime numbers, between 1 and that number, right? So if we take the CP array, right? So for CP of I, let me just put here, CP of I is equal to number of primes between 1 and I, both inclusive, right? This is what CP of I means, right? That is the number of prime numbers between 1 and I, both inclusive. Okay, great. So if I had to take up CP of I, what would CP of I be for each? There are 0, 0 because there are no prime numbers there. For 2, there is 1 prime number because 2 itself. For 3, there are 2 prime numbers. For 4, again it's 2 because between 1 and 4, there are only 2 prime numbers. Between 1 and 5, there are 3 prime numbers. Between 1 and 6, there are 3 prime numbers. 1 and 7, there are 4 prime numbers. 1 and 8, 4, 4, 4, 5, 5. right? So this is CP itself. But again, this itself doesn't solve the problem for us, right? We need to go one step further and we need to generate something else. Okay, so actually this will sort of solve your problem. This will kind of solve your problem if you go ahead and solve the question. So for example, if you look at the question over here, what have they asked? Between any two numbers, so between 1 and 10, can you tell me how many prime counters are there? Between so between, let's say, yeah, between 1 and 10, can you tell me how many prime counters? And then in the next one it says between 2 and 20, between 3 and 30, how many are there? So in this case, if you wanted to do it, the way you would do it is between 1 and 10, let's say you want to find out how many prime counters are there. In this range you want to find out, right, how many prime counters are there. You go to 0 and check. You don't start from 0, you start from 1. You check the 0. 0 is not a prime number. Okay, you check 2. For 2 it's 1. 1 is not a prime number, so you don't count it as a prime counter. When you go to 3, you check 3, it's 2. 2 is a prime number, therefore 3 is a prime counter. So you got 3 as a prime counter. Notice that I'm now noticing I'm shortlisting the indexes. Okay, 4 is also a prime counter. 5 is also a prime counter. Because why? Because its CP is prime. Its CP is prime. 6 is a prime counter. 7, 8, 9 is not a prime counter. 10 is not a prime counter. So now how many prime counters did we get from 1 to 10? We got 3, 4, 5, 6. Hence the answer is 4. So this is one such way that I can solve the problem, right? So one of the ways that I can solve this problem is that I generate the CP array. And once I've generated the CP array, for each element, I can go and check whether the CP is prime or not. And then I can increment the prime counter count. Okay. The problem with this approach, the problem that we're going to face with this approach, and yeah, I know it's a little bit confusing, guys. Don't worry about that. Or rather, you have to worry about that. All advanced questions are a little bit confusing like this. So you have to start worrying and you have to start concentrating more. So the problem in this is, you have something like this, right? Where the constraints are that between L and R, you're going to have 10 raised to 6. That is, you're going to have a 1 million possibility, right? That means that you could just be told, can you find all of the prime counters between 1 and 1 million, right? So that's number one. That's one of the problems. The other problem that you'll face is that you're not really in charge of the number of test cases. So let's say, we are going to start repeating certain tasks. Why? I say, okay, in the first test case, find out the number of prime counters between 1 and 10. In the second test case, find out the number of prime counters between 5 and 10. So again, you'll check, is 5 a prime counter? Is 6 a prime counter? Is 7 a prime counter? Is 8 a prime counter? And then I say, okay, find the number of prime counters between 7 and 12. You'll again check, is 7 a prime counter? 8 a prime counter? 9 a prime counter? And so on up until 12, right? So there is overlaps. There are always certain subtasks that you're always repeating. Whenever you face such a kind of a problem, right, where you're repeating certain subtasks, you use something called a prefix sum. Okay, you use something called a prefix sum or a prefix array, right? What do I mean by that? See, something as simple as, how did we even generate this CP of I? Okay, so when we were generating the CP of I, what did we do? We checked, okay, 2, how many prime numbers are there less than 2? There's only 1. This is the first one. 3, how many prime numbers are there less than 3? There are 2 prime numbers. But how did we check? We checked, well, if 3 itself is a prime number, then whatever the previous number was, add to it. Otherwise, don't add to it, keep the same number. For example, for 4, is 4 a prime number? No. But how do we know if 4 is a prime number or not? Well, you can check here, 4 is not a prime number. If 4 is not a prime number, it means that we are going to check our previous number. That is, previously there were 2 prime numbers. Therefore, for 4 also there are 2 prime numbers. So this prefix sum is the concept of borrowing from the previous result, taking the previous result we had, borrowing from it, and storing that. So this is how we'll generate the CP array. Now, using the same concept, okay, can I find out how many prime counters are there? If I had told you, forget prime counters, if I had told you, can you tell me how many prime numbers are there between 3 and 12? One of the ways you could have done is gone to the original prime numbers array and said, okay, I'll count between 3 and 12, how many trues are occurring, how many T's are occurring. The other way, the simpler way you can do is, once you've generated this array, you can simply say, oh, between 3 and 12, see, I know up till 12 there are 5, I know up till 3 there are 2. If you want to include both 3 and 12, it's basically just 5 minus 1. That means there are 4 between these, right? Because up until here there was 1. Starting from 3 up until 5 up until 12, there are 4 prime numbers, and that answer comes correct as well. You can check here, true, 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 true. 4 elements are primes themselves, and you could have got the same from this cumulative sum array, prefix sum array, whatever you want to call it. You got the same approach here. So this CP, calculating CP, becomes much easier if you borrow from the previous result rather than calculating again. For example, if I want to check for 7, how many prime numbers are there less than equal to 7, right? One of the ways I can do is go here and check, okay, true, 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 true. Or I can just say, hey, up until 6, how many were there? Up until 6, we already know there were 3. And 7 itself is a prime number. So I can make this 4 because I know up until 6 there was 3 and 7 adds 1 more to it. So it becomes 4, right? So I hope you understood this concept of the prefix sum and how we are creating this. So this creates a CP array. We are still not done with our question, but let's start implementing it because I think you might just get a little bit bored right now. So let me just start implementing this. Let's get the CP array, and with one tiny tweak, we will also get the prime counters array itself. We have to create another array for the prime counter. So let's go ahead and do that, and let's attempt this question ourselves over here. So let's do this one by one. I'll reset it. I was just doing this question before we started the session. So for the first line is input, int input. I'm going to do it in Python because it's a little bit quicker to write over here. You can do it in C++, Java. All of those languages are supported here, up to you. So you have t is equal to int input over here, right? Okay. Okay, so I have some questions in the chat which I'll come to at the end of the session. I just request all of you to stick around till the end of the session, and then we'll have a good conversation, right? So please stick around, do like the session so that other people can come to know about it. And really commendable to all of you. You know that CodeVita has been postponed. TCS CodeVita Round 2 has been postponed, and still you're sticking around in the session means you actually want to learn something, which is brilliant. Okay, so we have t is equal to int input, that is the number of inputs, and then for what we're going to have is we are going to get the limits. L and R are the limits. So I'm just going to say limits is equal to this. I'm going to create a list for limits, and I'll go for case in limits. So I'm going to go through all of the sorry, not limits, for case in range t. I'm going to go through all of those ranges, right? I'm going to go through all t because there are going to be t, L, R pairs, right? That are going to tell us, okay, between 2 and 20, you need to find out how many prime counters are there. So that's what we're going to get. And we're not, this is the trick, we are not going to get the answers of all L, R right now. We're going to store them. We're going to calculate the entire array, and then one by one, we're going to start getting the answers of L, R. Look at this trick. This is called the cumulative sum or the prefix sum array trick. Very, very important. Okay. So I want to take L, R is equal to list map int input dot split. It's just nothing but I'm just splitting the input that we have, right? We got the L, R, and we're going to say limits dot append. So we're going to append L, R. So that's what we're doing. We appended all of the limits. We don't calculate for any limits. We just appended all of the limits. And another thing that will be really interesting for us to know is max number, which is the max number, right? So I'll keep the max number as -1 right now, but we would want to get the max number. So max number is equal to max of r comma max underscore number, right? What this will do is it will tell us what is the maximum number possible, and up till that point we need to generate all the prime numbers because we need to know how many prime numbers are there, right? We need to know all the prime numbers up until that point. Why is that? Again, because we need to create that sieve. We need to create the sieve over here. We need to create this prime numbers array. For that, I need to know what's the maximum prime number I can expect. Hence, I'm doing this trick over here when I'm storing, okay, go through all the R's, and I know for sure that the R is going to be the maximum number because it's the right bound, the higher bound. So I got the max number over here, right? So I got the max number over here. Great. So I got the max number. Now what I want to do is, now I want to generate all of the prime numbers up until the max number itself, right? So first thing I'm going to do is generate the prime numbers. I'll just write down what my logic would be. Generate all prime numbers up until, until max underscore number, right? So you have to generate all the prime numbers. That's the first thing we're going to do. What's the second thing that we're going to do? Once we did this, generate a cumulative sum of prime numbers, right? Prime numbers, because this will be our CP array. This is our CP array, right? So we need to do two things. Let's first generate all prime numbers up until the max prime number. For this, we'll use a sieve approach. And if you don't know the sieve approach, we talk about the sieve approach in the Algorithms and Data Structures Bootcamp. We also talk about it in this CodeVita course. You can sign up for whichever one of them. I can't really explain the entire sieve. You can also look it up online. There are a bunch of tutorials on them as well. So what I'm going to do is I'm going to do 0 based indexing, and I'm going to say 1 based indexing, and I'm going to say max underscore number plus 1. So I'm just basically it's not even 0, sorry, it's going to be false. True, it's going to be true. And what we're saying is basically I'm assuming all of the numbers to be prime initially, right? And I can very quickly mark that 0 and 1 are not primes. They are not primes, so false, they are not primes. I know that 2 is a prime, so basically what I'll do is for factor in range 2 up until the length of the sieve. So I'm going to go from 2 up until the length of the sieve. And what I'm going to do is I know that 2 itself is a prime. So, 2 is true, it's marked true. And the way a sieve works is you're going to take 2 and you're going to mark all of its multiples as false, that they are not prime, right? So you're going to do for j in or the other way around. So anyways, for j in range factor into factor up until length of sieve, and I want to increase by factor, right? What did this mean? Basically from 2, I know that 2 itself is a prime. What I want to do is I want to start from 4, and then 4, 6, 8, all of those I want to mark them as not prime because they are divisible by 2, right? So sieve of j is equal to false, right? So we know that sieve of j is equal to false. That's what we're marking it right now, that this itself is a false number, right? So when I arrive at a particular sieve of I or whatever at a particular factor, I know that it's a prime number, right? So just to verify that this is working, this is not the answer, but I can just say if sieve of factor, that means if this is true, that means before coming to this particular factor, we could not find any factors of it itself, right? So that's why it's true. Let's just print the factor, right? So if we are correct over here, this should print all of the prime numbers below the first input, and I think the first input is 10, so it should print all of the prime numbers before that, right? Okay, we did not made a mistake here. Okay, right, so we got all the prime numbers from 2 up until 10, right? Again, this is a very standard approach of finding the prime numbers using the sieve of Eratosthenes. If you don't know it, please look it up. It's super simple. It's nothing difficult. In fact, I just wanted to show you that you can generate for any numbers. Let's say if I'd said generate up until 100, it's going to go ahead and generate all the prime numbers up until 100, right? It's the wrong answer, but we got the thing, right? So 2, 3, 5, 7, 11, 13, so on up until 100 with 97. 97 is a prime number. Interesting. So but yeah, so we got all of the prime numbers up until 100. So it works. This definitely works. This approach works. It's a sieve of Eratosthenes, and it generates all of the prime numbers. The most efficient way of generating a list of prime numbers. If you've just had to check the primality of a particular number, you wouldn't really use sieve. But if you want to just generate the entire prime number itself, the list of prime numbers, then the best thing to do is to use the sieve of Eratosthenes and generate all of the prime numbers, right? So that's one of the things that you pick up in when you start doing advanced questions. Anyway, so we did this. Now what I want to do is less than equal to this number, I want to find out how many such prime numbers are there, right? So when I go up to a particular number, I want to find out how many prime numbers are there. So see, I already know that if sieve of factor, it means that it is a prime number, right? So what I'm going to do is I'm going to say, let me take my CP array. So CP array is equal to 0 into max underscore number plus 1. So I don't know what it's going to be, but I'm saying initially, okay, there are 0 prime numbers. And what I'm going to say is that CP ARR of 2 is actually, leave this. We don't even need this. Okay, anyway, so we got this. Now what we can say is we know that if it's a prime number, then what do? We take, okay, how many prime numbers were there before me, right? How many prime numbers were there before me plus 1 if this is a particular prime number, right? So CP of factor is equal to CP of factor minus 1, that is take the previous one, and I say plus 1, right? But if it's not if this was not the case, right? So that is factor is not a prime number. It's not a prime number. So then what I say, CP of factor, just take this one, CP of factor, but I don't add it, right? So for example, if there are two prime numbers less than equal to 3, there will be two prime numbers less than equal to 4 also, because 4 is not going to increase the number of prime numbers, right? It's going to be the same as the previous one. Okay, so I did this. This is the number of, I got CP over here. Let me print CP, right? Just to make sure that we are getting the right answer in terms of cumulative or whatever the CP, that function itself that we have, right? So let's print CP itself. Okay. CP is not defined. Very good, because it's CP ARR. So let me just make it CP, right? Yeah. So you can see here what CP looks like. It's 0, 0, 1, 2, 2, 3, and 4 4s, right? And if I go back to the slides, that's exactly the same thing that we have. 0, 0, 0, 1, 2, 2, 3, and 4 4s, and then it goes on to 5 and so on, right? So I'll just confirm it's 0, 0, 1, 2, 2, 2, 2, and 3, 3. Yep, and yeah, correct. So that's correct. So we got this array. Now the tricky part comes is how many prime counters are there? That's the more important part, right? How many prime counters are there as such, right? Between these cases, right? So this will tell you CP. I want to find out how many CPs are there, right? This is the interesting part. How many CPs are there? So I have to create another one. Let me call this P counter. Let me call this P counter. So P counter of I, right? I want to find out P counter of I is equal to how many P underscore counter of I, how many P counter from 0 all the way up until I minus 1, sorry, up until I inclusive I, such that P underscore count such that they are prime, right? What do I mean by this? Let me just show you in this 1 second. Yeah, so what this basically means is, okay, I look at CP, right? Okay, this is the case. Yeah, so what I want to find out is, by looking at CP, I want to find out how many CPs are there such that they are prime. Okay, so now forget this one completely. Let's focus on this one. This 2 we can keep 0, right? When I'm at 2, I find that 1 is not a prime number, right? So I mark it as 0. Basically, less than equal to 2, there have been no CPs which are prime. There have been no CPs which are prime. If I go to 3, what it's telling me is there is 2, right? So 2 is a prime. That means that before this, I didn't have a prime. Now it becomes 1. Okay. When I'm at 4, I checked. This is a prime. This previous one was also 1. So I make this 2, right? When I'm at 5, this is a prime plus 1. This becomes 3. 6, this is a prime plus 1 becomes 4. So far we found 4 such CPs such that their CPs are prime. Right? So we found 4 such elements. Okay. For 7, it's 4. It's not a prime. So we carry over the previous value. Right. For 8, we found that it's not a prime. So we again carry over the previous value. Again carry over. Again carry over. That's why between 1 and 10, there are 4 such values. However, if I asked you between 6 and 10, how many values are there? There are 0 such values. Okay. If I ask you between 3 and 6, how many values are there? There are 4 such values, right? Because this is 4 minus 0 will be 0. If I ask you between 7 and 5, how many values are there? There are 2 such values, right? Those would be 5 and 6. Why? How did we get that? 4 minus 2. So again, standard implementation of our prefix sum of our cumulative array. It's a very standard implementation of that. Okay. And that's what we have over here. That's what we're creating. So we basically, what we did is we checked this value if it's prime. How do we know if it's prime or not? That we can use the first array. So based on the first array, you can find out if it's a prime, and if it's a prime, then you increase the number of counter from the previous result. Otherwise you keep it the same way. So we are having to use the prefix sum on a prefix sum on a pre-calculated sieve, right? That's the tricky part over here. That is something you needed to know. But if you know your prefix sums, if your prefix sums concepts are A+, like you know them, then this is great. And trust me guys, the prefix sums concept is a really important one. even in Hack with Infi, majority of the questions were on prefix sum, and Hack with Infi CodeVita round 2 question level you can expect to be similar. So please do learn this prefix sums concepts, which we do cover in our algorithms data structures bootcamp, and we also discuss a little bit of that in the CodeVita course as well, if I remember correctly. Anyways, so I want to generate now the prime counter array, right? So if I want to do the prime counter array, let me again create another cumulative sum array. Prime counter is equal to 0. It's the same thing. So this is the prime counter, right? And what I'm saying is, okay, let me just do it. So prime counter is here. Now, what I need to find out is, I'm also going through all of the numbers, right? When I'm at 2, right? When I'm at the second index, right? I need to find out if the CP of that second index is a prime or not. That's the first thing I need to do. So if CP of factor, okay, if CP of factor is prime, so that's what, if it's true, right? So if CP of factor is a prime number, what does that mean? If prime of CP of factor, that's what it means, right? So if, one second, sorry, not prime over here itself, it should be sieve. I don't know why I did prime over here, but yeah, sieve over here is basically equal to so if sieve of CP of factor, it means that if CP of factor itself was a prime, right, then what am I going to do? I'm going to say prime underscore counter of factor is equal to the previous one, prime underscore counter of factor minus 1 plus 1. That means the previous one, whatever the value was, plus 1 I'll do here. Else what am I going to do? I'm going to use the same value as the previous one, right? So I'm going to use the same value as the previous one that we have over here. Okay, all right, so we got this, we got all the prime counters. Let's print the prime counter array. Print prime underscore counter of the array, and we have that as well. It's like we've checked that in our slides also. So let's print that again. I hope there's no errors. Okay, so you can see here what we get is 0 0 0. That means up until 2 I did not have a single prime number, did not have a single CP that is prime, which is correct. For 3 we had a CP that's prime, so 1 2 3 4, and continues till 4 4 4. At 11 it becomes 5, and for 12 it continues to be 5. So we are stopping at 10. That's why we got this, right? Now the question is still not over, but it's almost over. So we got now finally our prime counters array. Now it's time to go and revisit our L comma R, right? So what we're going to do is, for case in range length of limits, right, or even T, right, we're going to go through all of those LR that we had stored earlier, and what we're going to say is L comma R is equal to limits of T. So we get those L comma R, and the answer for us is equal to prime underscore counter of R minus prime underscore counter of L minus 1, right? L minus 1. Yeah, this is what it will be. Prime underscore counter of R minus, prime counter R minus prime counter L minus 1. Okay, and then we print the answer. So we're going to print the answer over here, right? That's what we are supposed to do. Let's run this and check. Okay. Index out of range, yes, because it's not supposed to be T, it's supposed to be case over here. Okay, so let's run it. Yeah, and now we got the correct answer. Let me just submit and check whether it's passing all the test cases, or we're missing out some test cases. Okay, so we are definitely missing out certain test cases, but we're passing 2 test cases. So what could be the problem? One of the problems that I could clearly identify was that when we are doing something, so 1 second, we are not considering the case that L minus 1 could in fact become negative, right? So L is equal to maximum of a 0 comma 1 second. That's what's the best way to do this. L minus 1, right? So we do this, and so then here we'll use L, or again, not to confuse all of you, the simpler way to do it is this L minus 1 could become 0. So we want to use either 0 or L minus 1, right? Like for example, if it's 1, then we want to go up till 0, but if it's 0 itself, we don't want to do minus 1 of it, right? So that's what we get here. We run this. Okay, it still doesn't match. Let's see what are some possible cases that we may have missed out on. I'm just checking. 1 second, let me check if there's any. Yes, we've also missed out on one particular case, guys. I've just remembered. If you look at the case over here, there is one very specific edge case that they've mentioned. If no such number exists, you have to print none. So if no such number exists, you have to print none. So which means that if I look at it over here, if answer is equal to 0, if answer is equal to 0, then print none, right? You have to print none. Otherwise, you print the answer. So you never print 0 as such. You have to print either none or the answer itself, right? So that's what you're supposed to do. Now let's run and check. So run was working. If we submit, and yes, that was the edge case that we had missed. And why did that edge case bother us so much, by the way, was that because there could be, like LR means that like in each test case, there could be like about 5,000 or 10,000 such test cases. And each of those test cases could have so many answers that could come 0. So hence we need to put a none over there. Right. So just recap everybody. What did we do here? First things first is we calculated the sieve. I hope you understood how to calculate the sieve. This is how we actually generated the sieve, right? We using the same for loop. Once we've generated the sieve, you could have done this in 3 different for loops. You could have kept this and this in a different for loop. That is, generate your CP array separately, generate your prime counter array separately. That's completely fine to do. I just coupled them in the same one because the moment you arrive at a prime number, you already know if it's a prime number or not because of the sieve. That's the property of the sieve. When I come to, let's say 2, right? I already know that 2 is a prime number or not. If I come to 4, I already know if 4 is a prime number or not, because all of the factors of it would have made it as false if it was not a prime number. So if it's still true, by the time I arrive at that index, I know that it's a prime number, and therefore I can just use the same loop. I can sort of hijack the same loop to find the answer over here, and the answer becomes this only, that if it is a prime number, so if it's a prime number, that's what we do. What was I saying? Yeah, so if it's a prime number, then we say that, okay, increase the CP based on the previous value, otherwise take the same previous value. And now if the CP value itself is a prime number, then what you need to do is increase the prime counter, otherwise use the same prime counter as before. And the thing is, if you look at it, they stopped here, but they could have asked a question if that prime counter itself was a prime counter or not. So again, they could have done a bunch of other things there. They specifically didn't, but this just goes to show you that if you're really like the pattern you see here, if this, then do the previous one plus 1, else just do the previous one. This is a classical thing of this is a classical thing of prefix sums. This is a classical thing, and the thing is, the moment I saw that L comma R is there, I knew that it's a prefix sum question. So you need to get that intuition. You need to just look at the question and understand which prefix sum is it. Prefix sum, okay, and oh, I need to generate all the prime numbers between a particular range. That means it is a sieve question. So that's the good part about these questions, that once you look at them, you can very quickly understand them. I don't want to keep you longer and do another additional question, because as you can see, these are advanced questions. They take time, and yeah, it's some time before you actually have to go ahead and check out the CodeVita Round 2, because it's in February. So yeah, I mean, you're sort of saved from that one for now. To start preparing, one of the best things you could do is sign up for an advanced course. We have one, there are others as well, but I would really suggest, if you want to crack CodeVita Round 2, or if you want to crack any of the advanced companies and learn all of those advanced topics, do join our algorithms and data structures bootcamps, and we're happy to assist you in knowing more about that. You can go ahead and check out one free module. It already has some free questions from Google and Facebook and so on. All right. Let's look at some of the questions that you have over here. All right, so I'll just look at the question. I think some of the original questions were just about, we were a bit late, that's why. So I'm my apologies for that, right? So that's the thing. Okay, so somebody's asking CodeChef versus HackerRank, which is best for us to improve coding skills. Both are, I think, roughly at the same level when it comes to the kind of questions you get. None of them will actually probably have detailed tutorials on how you can solve them. So if it's just a practicing platform, I think you can go ahead with any one of them, it's fine. But if you want to really learn a certain thing, I would really suggest you join any bootcamp on advanced algorithms. Do we need to register again for round 2 after qualifying round 1? All of those logistics and details, if you've cleared round 1, you will get an email from TCS. You will get all the instructions from TCS or from your placement officer. Don't listen to anybody else. Listen only to your placement officer and TCS, and they'll tell you exactly what to do. So nobody knows anything yet. It's in February. It's a long time away. So wait for that, right? Okay, in my campus commune page, it shows like tomorrow is the second round. So I guess refresh it. I don't think the internal page has yet been refreshed. I'm not sure, but I don't think it's there. I don't think it's tomorrow. Otherwise, there would have been much more intimation from TCS CodeVita itself, right? So that's the other thing. Okay. Sir, I am in third year of engineering. I have cleared in round one. What is opportunity for me? So the best thing that you could do is you can actually attempt round two if you have been cleared for it. And I know that TCS creates an active profile of you and they start shortlisting you for internship opportunities and other special opportunities. So definitely there is a lot of benefit for you if you go ahead and solve these questions. Okay, all right. Okay, for CodeVita round 2, will Edyst give another test pack, or the previous one will be available only? We don't have a special round 2 test pack. We will keep updating the questions on the round 1 question test pack itself. So that's not a round 1, that's a CodeVita test pack. We'll keep updating the questions over there. Okay. Okay. All right. Are there any free bootcamps for data structures and algorithms? No, unfortunately, we don't have any free bootcamps for data structures and algorithm, simply because it takes a lot of time, effort from mentors to be online to help you. This again is live sessions. You will have a lot of live sessions with me personally. This is not something that can be offered free, right? So that's the thing. Okay. All right. Very, very useful session. Thanks so much, Khaja Moeddin. Nice to see you again on our sessions. Akash, are they going to mention explanation of all question? Yes. So we have weekly sessions where we do a lot of discussion upon all of the topics covered that week. I personally am taking those sessions. So you'll get one-on-one Zoom sessions with me. Like it'll be like just like 10-15 of the chosen students together with me, and we can actually discuss all of your doubts and questions. And as you know about me, I don't wait. I don't have a particular timing. If your doubts take 3 hours, I will spend 3 hours with you. So we really care about the success of our students, right? So that's the thing. So yes, definitely we have explanations of all the questions on this particular platform for this advanced course. When will be your next session? Sort of the next session will be actually on Monday itself. We are doing one session almost every day these days. Please subscribe to our channel and also hit the bell icon so you come to know exactly when we are doing our next session. So sort of, I hope that answers your question, right? Okay, so I think that's probably it, guys, from you guys. Then I don't see any more questions. Thanks so much for attending our session today. I can for sure tell that whoever attended our session today is really, really serious about CodeVita round 2, because the round 2 has been postponed and you still stuck around and you still watched the session. So it's brilliant to see that. I love your enthusiasm. Keep going. I know a lot of your friends might just be enjoying and all of that, whatever. You are not. You're actually spending time on placements. You will get the reward for it. So go continuously do this. You're going to do great, right? Wishing you all the best. Hi sir, can I apply for CodeVita as I've already offer in TCS? CodeVita application date is already over. If you didn't participate in round 1, then you can't really participate in round 2. So round 2 people, you must have participated in round 1, only then you can go to round 2. So if you've already participated, then you can. Otherwise you can't really. If you already have a job offer and you're thinking of should I participate in round 2 or not, you should definitely, because there is chances that in round 2 you can get offered a higher package of a digital package or something. So Khaja Moeddin is asking a question about what are the major topics that we should prepare for round 2. We discussed it at the start of the session. I'll just cover it. You have all of the major topics. Generally I have seen advanced maths, arrays, backtracking, DP, all of the graph algorithms. Sometimes it's like a straight implementation of the graph algorithm. So don't try to derive all the graphs algorithms or any of these algorithms on that particular day. You can continue using all of these giants have created these algorithms, so you can do that, right? Okay, so yes everyone, that's mainly it from our side. Any other questions or doubts, do let us know, right? right? And yeah, do subscribe to this channel. We are going to give you many more such things. I cleared round word. Am I eligible? No mail yet. Okay, till you get a mail, please don't assume anything, and the mails will be delayed because the round 2 is on February 6th, I guess. Anyway, just check out campus compute. It's much later. It's not now. Round 1 is not tomorrow. It's not on 7th November, right? Okay. All right, guys. Thank you so much, everybody, for joining in. That's it from my side. Wishing you a great weekend, right? And all the best. And yeah, hoping to see some of you on the Advanced Algorithms Bootcamp. And I'll catch you all next time. Thank you so much, and I'll see you later. Bye bye.